Welcome to the final video of our redundant switches course. Over the past few modules, we've walked through the fundamentals of redundant switching, its importance in network reliability, and best practices for setup and configuration. Now, we've reached the installation and troubleshooting phase. In this final lesson, we'll focus on the critical steps to ensure a successful installation of both outdoor units, ODUs, and indoor units, IDUs, as well as how to troubleshoot effectively when things don't go as planned. Installation and Troubleshooting, Chapter 5. Let's go through the installation steps for the redundant switch system. This process ensures a smooth setup, proper connections, and system integrity. First, we'll begin by setting up the outdoor unit, ODU, and indoor unit, IDU, ensuring proper placement for optimal performance and access. Next, we'll connect the ODU and IDU using the appropriate cables, making sure each connection is secure and meets the necessary standards for reliability. Then, we'll go over the crucial grounding procedures to prevent electrical faults, ensuring safety and stability in your setup. Finally, we'll verify both power and RF signal integrity to confirm everything is functioning correctly and to prevent potential issues from affecting your network. Let's dive in and break down each of these steps to ensure a smooth installation and troubleshooting process. The first step is the ODU setup. Please notice that Norsat will ship LNB integrated system typically, so this step only applies if you use your own LNB or in case the LNBs need to be replaced. ODU setup. Firstly, install the LNB onto the waveguide bend using 4x screws and washers. Then connect the LNB cable from LNB port on the controller box to the corresponding LNB. After the LNB integrating, mount the ODU close to the feed interface, mounting the plate such that switch inputs are close to the feed. Ensure all cables are properly routed to avoid interference or damage, AC cables. Connect the RF input and output cables securely, ensuring minimal signal loss. Then we need to set up the IDU. First, we need to securely mount the IDU to a 1RU rack using the appropriate fasteners. It's important to ensure that there is proper airflow around the unit to allow for adequate heat dissipation and prevent overheating. Next, we connect the Ethernet RJ45 connector from the IFL, interfacility link, to the ETH-ODU port on the IDU. This establishes communication between the indoor and outdoor units. After that, we connect the network port to an external network connection. This allows the system to interface with other networked components and enables remote access if required. Now, we connect the ACIN port to the IDU power cable, ensuring a secure connection. Once everything is properly connected, we power on the system and check that it boots up correctly. As mentioned in slides before, the IFL cables kit consists of one power cable, one Ethernet cable, and one RF cable. Follow the picture of port instruction, connecting cables between IDU and ODU. Each power cable requires a power plug corresponding with the region it will be installed in. Attach the RF cable to the IF-out1 connector as shown below. Connect the other end of the RF cable to a modem receiving port. Attach the AC power cable to the power plug adapter. Attach the AC power cable to the ACIN1 connector on the ODU. Ensure that the cable is threaded onto the connector. Attach the Ethernet cable, Amphenol circular connector end, to the ETH connector as shown below. Connect the other end to a RJ45 port or the RJ45 port on the IDU. Secure grounding. A safety ground connection point is provided on the ODU and IDU. If the AC power input has no earth ground, connect one at the ODU grounding point and IDU grounding point. The grounding point locations are shown below. Now, let's move to the buck redundant switch installation. Similar as LNB redundant switch, Norsat will ship buck integrated system typically. This slide only applies if you use your own buck or in case the bucks need to be replaced. Firstly, install the buck onto the WG bend using screws and washers. Then, secure the buck onto the buck bracket using the appropriate screws. Finally, connect all cables including power cable, M and C cable, and RF cable. Similar as the IDU of LNB redundant switch, the IDU of the buck redundant switch need to be securely mounted to a 1RU rack using the appropriate fasteners. It's important to ensure that there is proper airflow around the unit to allow for adequate heat dissipation and prevent overheating. After the IDU has been set up properly, the next step is to connect it to the ODU. First, take the RF cable and securely attach it to the FIN connector on the device. Next, connect the other end of the RF cable to the transmitting port on the modem. This allows the signal to be transmitted properly. Now, take the AC power cable and plug it into the power plug adapter to prepare for power connection. Then, attach the AC power cable to the AC-in connector on the ODU outdoor unit, ensuring a firm connection. Make sure the cable is properly threaded onto the connector to avoid any loose connections that might cause power issues. Now, connect the Ethernet cable to the ETH connector on the device. The other end should be plugged into an RJ45 port or the RJ45 port on the IDU indoor unit for network communication. Finally, power on the system by connecting the AC power cable to a power source. Once connected, the system should begin operation. With these steps completed, your system is now properly set up and ready for use. Now, let's talk about an essential safety step for buck redundant switch, grounding the system properly to ensure safe and stable operation. Both the ODU outdoor unit and IDU indoor unit are equipped with designated grounding connection points. These points are specifically provided for safety purposes. If your AC power input already has a proper earth ground, additional grounding may not be necessary. However, if the AC power input does not have a reliable earth ground, it is strongly recommended to establish one. In such cases, connect a grounding wire to the ODU grounding point and another to the IDU grounding point to ensure electrical safety and proper system performance. The exact locations of these grounding points are shown in the diagram below, providing guidance on where to connect the grounding wires effectively. By following these grounding steps, you can enhance system reliability and reduce the risk of electrical faults. Now, let's move on to an important section, troubleshooting. Issues may arise with both the outdoor unit, ODU, and the indoor unit, IDU. This guide will help diagnose and resolve common problems. Let's talk about when the web interface cannot be reached. What should we do? First, verify that the ODU power connector is properly seated and threaded. Second, verify that the Ethernet connector is connected and locked at both ends. Third, on a computer attached to the redundant switch network, open command line and ping the IP address. Default is 192.168.77.30. If the IP address is reachable, try loading the web page using Firefox. Fourth, if the system includes the optional IDU, check the ODU IP settings in the network settings page and confirm that you are accessing the correct address. Fifth, disconnect and reconnect the Ethernet connection on the client side. Sixth, power cycle the ODU. Seventh, use an IP scanner to search the network for the device's MAC address. Next, if the IP address has been lost, a hardware factory reset may be required. Finally, if the problem persists, contact customer support. In some cases, you may encounter a server-related error, like the one shown here, syntax error, unexpected identifier server. By following these steps, we can systematically troubleshoot and resolve connectivity issues with the ODU web interface. Now, after confirming that the web interface is working correctly, the next step is to check the device configuration in the GUI when you are unable to use the LNB or buck. You need to ensure that the device configuration settings match the actual hardware setup. Any mismatch can cause issues with LNB or buck functionality. In order to make the system operating, the operator is required to power cycle the system, which is disconnect the AC power and reconnect it. If the web interface changed after reconnecting the AC power, it means the configuration is not set up correctly, which usually caused by the locking ODU production settings. If the signal is abnormal, we need to systematically check to identify potential issues. Check the connection, ensure all cables are securely connected and there are no loose or damaged connectors. Power for ODU, verify that the ODU is receiving proper power. If power is missing, check the power supply unit and cables. Also, you can check if any system power fault is present in web interface as the picture shown in previous slide. If there is a power fault detected, go next step to check ULC configuration. ULC configuration check, double check that the ULC settings are correctly configured. The redundant switch has an integrated ULC can be configured by the user. When the ULC setting is enabled, both the active and standby LNB receive power from the ULC. If the LNBs are being powered by the onboard ULC, open the ODU web interface and confirm that the ULC is enabled. 2. If the LNBs are being powered by an external source, ensure that power is being applied to the system. 3. If the ULC is enabled, disable the ULC and then enable the ULC. 4. Power cycle the ODU. Check GUI for faults, Look at the system's GUI to see if any fault messages are displayed. GUI to check LNB current. Monitor the LNB current in the GUI to ensure it is within the expected range. Verify it receives 10 MHz. Confirm that the LNB is receiving the required 10 MHz reference signal. By following these steps, we can systematically diagnose and resolve any abnormal signal issues, ensuring optimal system performance. Buck rejoint switch troubleshooting checklists. Power to ODU. Ensure that the outdoor unit is powered properly. Power to buck. Check that the BUC itself is receiving the correct power. Here are some tips for checking. First, you can check the LED on BUC and see if it light up. Second, check if the internal fan of BUC is operating. Third, check the GUI and see if there is any current fault. Check GUI for faults. Look at the GUI for any system alerts or fault indicators. Check GUI for redundant switch faults. Identify any issues related to the redundant switch in the GUI. Check BUC GUI for faults. Navigate to the BUC specific GUI to review any error messages. Verify it receives 10 MHz. Make sure the BUC is receiving the 10 MHz reference signal as required. By following these steps, we can systematically diagnose and resolve any abnormal signal issues, ensuring optimal system performance. For this slide, let's talk about the scenario when IDU cannot communicate with ODU. If there is a connection error between the IDU and ODU, the system will display an error message stating, "Error, there is no connection with the ODU." The first step is to verify the physical Ethernet connection between the IDU and ODU. A loose or damaged cable can cause communication failures. Next, access the web interface for both the ODU and IDU. The IP addresses are 192.168.77.30 for the ODU web interface, 192.168.77.31 for the IDU web interface. Navigate to the device setting page and check the SNMP version settings. Ensure that the SNMP versions of both devices match. If they are different, communication may fail. If the problem persists, further troubleshooting or reconfiguration may be required. Congratulations! You've made it to the end of the redundant switch training course. You've completed all the lessons, learned key concepts, and are now equipped with the knowledge to navigate and implement a robust redundant switch system. Stay tuned for our next video course, where we'll dive into even more exciting topics. See you soon!